correct statement. So pick the correct statement. So first point is ki average speed of the particle in a given time is never less than the magnitude of average velocity. So this can be explained in this way. Suppose A is the initial position, B is the final position. Suppose particle moves in this manner from A to B. In this case we can say ki average speed, average velocity is this. Average velocity is from A to B. Suppose particle moves in zigzag manner, so this is the average speed, because this is the shortest distance, so this is the average, this is the displacement, so this is the average velocity, and this is the speed. We can write ki speed is greater than velocity, so it can be written ki speed is greater than velocity. As speed is greater than velocity, average speed of the particle is never less than the average velocity. Yes, speed is greater than velocity. Speed is greater than velocity. So average speed of the particle in a given time is never less than the magnitude of average velocity. Yes, this option is correct. Yes, this option is correct. In the second case, it is possible to have a situation in which dv by dt is not equals to 0. dv by dt equals to acceleration that not equals to 0. When body moves on a circular path, centripetal acceleration is directed towards the center. So in this case, acceleration is not equals to 0. And change in velocity that equals to 0, as for one complete rotation, displacement is 0. So velocity is also equals to 0. In the third scenario, so this is correct, this is also correct. The average velocity of the particle is 0 in an interval. Average velocity is 0 in an interval. So when body moves on a circular path, yes, average velocity is 0. And it is possible that instantaneous velocity is never 0. Yes, whatever be the instant, instantaneous velocity is never 0. Instantaneous velocity is never 0 because particle moves with a constant speed. So instantaneous velocity is never 0. Instantaneous velocity is never 0 in this case. With D scenario we can see, yes, this option is also correct. Option A, B, C are correct. The average velocity of the particle moving on a straight line is 0. Let's take an example. Suppose particle moves from A to B and moves in a straight line path, then returns from B to A in also straight line path. Particle moves from A to B in straight line path and returns from B to A in straight line path. In this scenario, displacement is 0. In this scenario, displacement is 0. As displacement is 0, velocity is also equals to 0. As the displacement is 0, velocity is also equals to 0. As velocity is 0, yes, first part is satisfying. Average velocity of the particle moving along the straight line is 0 in a time interval. Is it possible that instantaneous velocity is never 0 in this interval? So when looking into instantaneous velocity, when a body starts from point A, initial velocity is 0. So when body returns from B to A at the turning point, velocity is also 0, reduced to 0 somewhat. So when reaches at point A, at that point also velocity reduces to 0. So there is a possibility, yes, there is a scenario is there, at this instant instantaneous velocity might be 0. So there is a possibility, yes, there is a possibility instantaneous velocity might be 0 at any instant. So this is not correct. So answer is option A, B, C are correct.